Hi everyone. So our next topic is design pattern. So in the design pattern, as we know, we are going to find the common solution to the pattern among different software problems. So that's what the design pattern is. And the first pattern, or you can say a method that we are going to study is the factory method. So factory method provides an interface to create objects in the superclass. So what it says is that if you want to create different type of objects, if you need to create different type of objects in your software problem for which you are designing, then you should create object in the superclass, right? So just say that, okay, create object in the superclass, not create any specific object, just object, and allow the subclass to alter the type of the object. So here you will say, okay, create an object, but what type of objects will be created? That will be in the in child classes. So the subclasses will decide what type of objects are created, and the superclass is an interface or an abstract class. So we need an abstract class that create an object but does not specify that which objects. So this will help us to extend the type of the objects that we want to create, right? So that's the benefit here, and we can use the dynamic binding here. So the functions can be defined, the sub, as we know, the we can define, we can get the pointers or the objects of the superclass, and then at the runtime we can assign the objects to that pointer, right? So that's called the dynamic binding or the runtime polymorphism, and we can have a virtual constructor in the superclass without specifying the exit class that will be created. Let's say that we are working for a logistic company, and that company handle the road logistics but now wants to offer the sea logistics as well. So if it's a road logistics, maybe they have the trucks, but now as they want go for the sea logistics, so they need a ship to be also be created. So how are we going to incorporate the sea logistics when already using the trucks? So we need to replace the direct object in case this software is already built and there is a function that creates an objects like truck, create trucks, and assign some functions to truck. So we need to replace that object construction call with a special call to a factory method. So we'll say create transport, create an object in the superclass, and then there will be a subclass that will create a specific type of object, maybe a truck or maybe the ship. So objects returned by the factory method are called the products. So this is a UML diagram that says that first you will have a product, and this is the abstract class, is an interface, and it will do some functions like do stuff, something. So this is a product class, and then from the product class we can have two child classes. So that's the product A and product B, right? So here we can say that, okay, yeah, create truck and maybe create ship, but this just define, this is a class only, we have still not created the products. So we defined a product class and two classes that are for the different products, concrete products, and this is an abstract class, right? Now based on this pattern, so we'll create a factory method. So this is our factory method, create product. In a creator class, we'll create a creator class. So creator class will create a product of this abstract class, right? But this is again a virtual function here, the create product. The actual products will be created by concrete creators. So we will create a subclass concrete creator A, concrete creator B, and in this we'll create product, and this create product will create a concrete product A, and this create product will create a concrete product B. And some operation can this operation can directly be on the product, right? Not on the abstract product. And the abstract product has do stuff, so here we can say do stuff, something like that. Okay, so in case we get another product, so we can say, okay, concrete product C, and then we can add another creator. So in this way we can extend our software. So this is an example of the factory method where this is the product, and we have a destructor, which is the default destructor. This is also virtual. So in case we have child, well, of course we are going to have the child classes, and we are going to the override this destructor, as well as this is a virtual also. This is an operation in case we have some operation. So this is a virtual operation, and this in case we have non-virtual also, we can keep that. So this is an example of the virtual operation. Now we are going from this, we are going to the first step. Yeah, that's the first step we have done. Now we are going to the second step by creating the products A and product B. So now we're going to have product A and product B. So this is our concrete product 1 and this is our concrete product 2, and we need to override this operation, right? And this we need to override this operation here. So different implementation of the functions in different concrete products, and there is no other virtual, so only these things were, and this will be the default destructor will be here automatically. Okay, so now in the we step is the third step, create class. So creator class. So the creator class will have a factory method that will create objects of the product type, the abstract objects of the abstract class interface. So we'll have a factory method need to be declared in the creator class that returns objects of the product class, and the subclasses. So we're going to have another creator, maybe concrete creator 1, concrete creator 2. So subclasses of the creator class will define the factory method. So this is our creator class. We have the virtual destructor which is default, and then this is the factory method. Maybe we name is factory method. You can have create product as well, whatever. So this is a factory method. The idea behind factory method is it will return the product, and this is a virtual, and this product is also the virtual object from the interface, and it's a pure virtual function. We say it's equal to 0. This is a pure virtual function. Okay, now this is a sum operation, so we can have non-virtual function as well, sum operation here, and this sum operation can be the operation that is defined on the product, which is the do some stuff. Okay, so in the sum operation we say get a product first, because operation needs to be applied on some object. So it's saying get the product using the factory method. So you just get the product, and then we are doing this operation, and this operation is which is the operation defined on this product in the abstract class. So this must be in the abstract class, and then we're saying whatever, and then we're going to delete this product and then return. So there is no object leakage. So we have done the operation by creating the product, done sub operation, and then return the result. Okay, so next we need to have concrete creators. So concrete creator 1, so we need to define the factory method, and then in the factory method we will write we'll create a product of the concrete product 1. Similarly, we will have a concrete creator 2, and in this case we'd say concrete product 2, right? So we have concrete product 1, we have concrete product 2 in different creators. Lastly, we need to have a client code, and that client code will work on the creator. It will take the creator and will do the operation, right? And this creator during the runtime, we can pass concrete creator 1, we can pass concrete creator 2. So we have the concrete creator client code. It is accepting the creator, and we're saying okay, result creator dot, we can call some operation on the creator. Okay, and that's the result, and we say okay, so we say result, and next we need to write the main function. In the main function we are saying create a pointer of the concrete creator, create an object of the concrete creator. This is creator 1, and we pass this creator 1 to the client code, and next we create concrete creator 2, and then we pass this object also to the client code, and this client code can handle both the creators, whether it's creator 1 or creator 2, because it is mainly used for the base class, right? So it can during the runtime you can pass the objects of the child class and it will work perfectly because of the runtime polymorphism, and this will be the output. So now your same client code will work for all of the objects. So this is how you can add ships or maybe aeroplane into the existing logistic class. Okay, so now let's do this same operation, the same example for actual the logistics problem. So just a summary, we need to first have the abstract product interface, abstract class or the interface for the product. Then we have the concrete product A, concrete product B, concrete product 1 and 2, and then we need to have a creator class. Then we need to define concrete creator 1 and concrete creator 2. That's it. These are the 5 classes will be 6 classes will be required. And in the concrete creator we will have some operation and the create product, but this create product will be defined here. So this is a virtual here, some operation will call this do stuff here. Okay, so let's do the same example now for the logistic company. We need to have a class called transport, we need to have a class truck, and we need to have a class ship. So this is a transport, this is our first product class. Then we will say truck, a subclass from the transport, ship subclass of the transport. So we'll have 2 concrete products ready. Now next is the creator. So this is the creator logistics. Then we say concrete creators, which is the road logistics subclass from the logistics. And then we have the sea logistics subclass of the logistics. Then we have the client code, and this client code will be the subclass from the logistics. And then we have the main. Okay, so now let's see the transport. In the transport, we'll say the virtual destructor, that's default, and then we'll say, let's say that we have a function called the deliver. Okay, so we have deliver. This deliver is a virtual function, and okay, so it just said the product delivered using this transport. And now next we have the truck. The truck is a subclass of transport, and in this also delivers, but it says delivery by the truck. So deliver is a virtual function here, and all the subclasses will define their implementation of the deliver. So truck will deliver by some other means, so we'll say delivery by truck, different prices, different routes and everything. So, and in the ship we'll say okay deliver, and we'll say delivery by the ship. Right? So we have created successfully 1 product class and then 2 child classes, truck and the ship. The next step will be for us is to first write the logistics, which is the creator class, and then from the logistics we'll say concrete creators, concrete creator, concrete road logistics, and concrete creator 2, which is the ship logistics. That will get us. So in the logistics we are saying that the destructor, which is the default, and then we have the creator transport. This is our factory method, and this is a virtual, so it does not specify here the which transport is to be created. This will be defined there. And then we have the planned delivery. So this planned delivery will call the delivery by the product. And okay, this is the planned delivery. This is also this is to be, this we can define it here, planned delivery. No need to create the virtual, because this planned delivery can use the product returned by the create transport and can call the function that is of the delivery, right? So we have the planned delivery, so it can call the create transport on this, and we get the transport, and from this transport we can say we can call the deliver, and we get the result, and then we can delete this transport and we can return the results that the product is delivered. Now we need to get concrete creators. So road logistics, in the road logistics we'll have now we'll need to define the create transport, because create transport is a virtual function. So create transport will override this and will say new truck assigned to transport, and then return this transport. And if it is the C logistic, which is the concrete creator 2 subclass of logistics, so we'll say again in the create transport, and we'll say now new ship, and then return this transport. So we are creating the transport, actual transport, in the road logistic and C logistic, and returning this transport. Right? So this is the work of this one. So next step is to create the client code. So what is the client code? Client code will accept something related to the logistics, not the C logistics, not the road logistics, but actually the logistics. Okay, so this is our client code. So this is a client code will accept some reference to the logistics, and then it will call the plan delivery on that logistics, because this plan delivery is a function, member function of the logistic class, so it can be called, right? And we can say, okay, this is the message working without knowing the creator class, whatever you want to say, that's the you can return a string from that, or you can print this message because client code is void, or if you want you can return this also. Okay, so we return. Okay, so that's the client code. Next step is the write the main function. Now in the main function we are saying that create object of the road logistics and pass this to the client code, and similarly we can have an object of the C logistics also and can pass to the client. So the client code can handle all types of objects. So our application can handle all types of object, whether it's road logistics, whether it's a C logistics. So this, in this way our program is very good. So that's the factory method function. Okay, so we'll get the output of this one. Next is the abstract factory. So we are going to create families of the related objects. Create families of related objects, right? So let's see this example first. What do we mean by the related objects? Let's say we have a furniture shop and we have some different types of products, maybe chair, sofa, coffee table, and there are some different varieties also. There are related varieties, Victorian, modern, or maybe some other flavor of that. So it can be for a restaurant also. We have tea, coffee, then we have hot and cold. So there are different versions, different related products and different versions of that. And we know that if somebody wants to have a particular Victorian furniture, then it's going to have all of these related. But it's unlikely that you will have a chair Victorian and then sofa maybe modern. So this is not going to work. So in most of the cases, people are going to buy one particular product family of related products. So that's the furniture shop. Okay, so abstract factor solution is, first you need to define we should define interfaces for each distinct product. So whichever products you have, so we must have some interface for that. So interface means we need to have some abstract classes. So we are going to have 3 abstract classes, because we have, in this case we have 3. If your software has thousands of product, then you need to have thousands of abstract classes. So we have chairs, we have sofa and coffee table. So we need to have 3 interfaces or 3 abstract class. Next, we are going to implement product variant. So we are going to implement Victorian chair, modern chair, Victorian sofa, modern sofa, Victorian coffee table, and modern coffee table. So this is how we are going to define. Next, abstract factory create abstract product. Now there will be an abstract. So these are all the classes that we have created. Next will be the factory method. So we will need to create first abstract factory that will create abstract product. So that will create chair, that will create sofa, that will create a coffee table. So again, the abstract part, as we earlier also we created the abstract product as a transport, which are the abstract. Next, you will extend this, implement concrete factory. Now concrete factory 1 for Victorian, concrete factory 2 for modern version. Next, we will have a client code. So client code will accept the abstract factory, this one abstract factory, and then main will create the concrete factories and will pass this to the abstract factory. Like, it's very similar to that. That's why it's called abstract factory pattern solution. So we need to have abstract product A, abstract product B, and abstract product C. Like, so one can be chair, another can be sofa, and the third can be coffee table. Okay, now next will be to create concrete product A1, concrete product A2. Right, so there are 2 versions in our case. So we have concrete product A1, concrete product A2, and this will be extended from the abstract product A. Next we have B1 and B2, again from the product B, and next we have the product C, and from C we'll create C1 and C2. Again, if you can say this is a Victorian chair, modern chair, Victorian sofa, modern sofa, Victorian coffee table, and modern coffee table. Okay, so we have these 6 classes here. Now we need to have an abstract factory. So we'll have an abstract factory. So we'll say, okay, create a class abstract factory, and in this class, from this abstract factory, we'll create multiple factories. We'll say concrete factory 1, concrete factory 2 subclasses from the abstract factory, and then we'll say create the client code. So this client code will work with the abstract factory, right? And then finally we can define the main. Now let's implement this abstract factory. This was very high level overview. So this is our abstract product A. So we'll need to define some destructor and then maybe the function, some function that we want in the abstract. So any common function. This is an abstract, so this is a virtual function. So the name is same, but everything is for set. So maybe we can have a sit on, right? So we know that this is a chair, so chair can be the role function is sit on, and then we can have a different implementation, whether it's a Victorian or whether it's a modern, right? So function A, and then we can have abstract product B. Abstract product B is define the destructor, so it can have a virtual function, it can have another function that collaborates with abstract product A. It's possible that you need to interact both the products, right? So in that case you will have a collaborator, but that will be of another product, abstract product. So instead of linking it with the child classes, so you need to link everything in the abstract class, and later on you can pass and link anything with anyone, right? So you have the flexibility, you got the flexibility. So then we have the abstract product C. So we have the virtual destructor default, and then we may have a function D, which is in both the versions of the product, right? So what will the next step? Next step will be define the concrete product A1. So in the concrete product A1 is a subclass of abstract product A, and we need to define the function A. We'll say result of A1, right? So then we have the product A2. Again, from the abstract product A, we'll say result of A2. So we have defined both the Victorian chair as well as the modern chair. So both the versions of concrete versions have been created of the abstract. Next is from the B1. So we have the Victorian sofa, we have the abstract product B, and we'll create concrete product B1, and concrete product it has. So in this case, we have two functions actually. One is with the collaborator and one is without collaborator. So we need to define the both. So in this function B result of B1 and this function C accepts some collaborator here and of type abstract product A. So we're going to define, okay, so this will take the collaborator, and the definition is it will call the function A of its class and say that B1 collaborated with this result and return the result. So okay, so we created this collaborative product. Then we have the modern chair. So in the modern chair we have abstract product B, and then we have the concrete product B2. So this was also from B, right? And this is now we already created B1. Now we are going to create the B2, and we implemented function B and as well as function C with the collaborator version. Next we have we need to create C1 and C2 from the C. So we're saying C1 and function D and result of maybe C1, and similarly we'll say C2 result of C2. Okay, so this is our abstract factory. So it will say, so we have created all the products, so now we are going to create the factory. So we'll say create product. Earlier it was only create product, but now we are going to have multiple products. So create product A, create product B, and create product C. Earlier in factory method, we have only one product. Create ship, create transport, and then create truck or create ship. Like so, create product A, create product B, and create product C. Okay, so now we are going to have the concrete versions of these factories. So we'll say concrete factory 1. So concrete factory 1 is a subclass of abstract factory, and in this factory 1 all the products will be of type 1. So we'll say A1, B1 and C1, all of one version, A1, B1, C1. Similarly, factory 2 will have A2, B2, C2, create all the products of that version, right? So that's the concrete factory 2. Now in the client code, you will accept this factory here, and then client code will call create product A, create product B, create product C. So now A, B, and C, create product A will create, depending on, so it will create a product of some product A, product B, and product C. And now we can call some functions from on these products, and also we can say in case we want some, there were multiple function with the collaborator function also, we can say product B can collaborate with function A, and then finally we can delete, right? This now, this client code will accepting the abstract factory, so it is really not creating product for any factory 1 or factory 2. So in the main function you can create pointers of the child classes. We can say new concrete factory 1 and pass it to this one, and this client code can handle this concrete factory 1, right? So cf1 will go here and will call create product A, create product B, create product C. If it's c2, then c2 also call create product A, create product B, and create what actually will be created when you pass c1. It will create A1, B1, C1, and it will pass the other ones. Will say A2, B2, and C2. So in this case, it's a CF2. So the version 2 will be created, and both the products can work in this same application. So that's the abstract factory method. Okay. So maybe you can take an exercise here. So we have the products, and now you can write the classes for all of these products, right? So we'll write a class which is chair and maybe has legs and sit on, right? So that's the abstract class, and then you will define has legs, sit on, has legs, sit on in the Victorian and the modern. Similarly, we will have a furniture factory. That's the abstract factory. Abstract class will say create chair, create coffee table, create sofa, right? And this coffee table will collaborate with the will return the coffee table, will return this chair, and will return the sofa. And in this case, we'll then extend our furniture factory with the Victorian furniture factory and the modern furniture factory, concrete creators, right? So we'll have a create chair, create coffee table, and create sofa. So all of these will create A1, and these will create the A2. The next is the builder class. So complex products, so step by step. So this is a bit different from the factory methods. So in the builder class, we have when we have a complex steps like complex product. So what do we mean by the complex product actually? Let's see the example of a house. So extending the base house class may not be a good idea always with lot of base classes. So now currently what we've done is we defined an abstract class, and then we extended that created the concrete classes with different extensions. So one was Victorian, other was the modern. Earlier also create transport, and then we extended. But if we are going to have a lot of base classes, then it doesn't make sense, right? So there will be lot of versions, and some of the classes will never be used. Extending the base class may not be good idea with a lot of classes. Like we have a house, we may have a house with garage, we have a swimming pool, garden, and so many things in the house, right? So how many house extension classes you can create, right? So there is always a limit here, and you will always be short of that. So what's the solution here? So solution is to use the builder design pattern. So constructor with even you can have a constructor to pass these values. Even that is also complicated. So you may have defined certain parameters. Okay, we will pass, and then based on that the objects will be created. But we are going to have a lot of nulls here. Not all houses will have a lot of things. Like so windows, doors, rooms, has garage, swimming pool, garden. So you can create a house like this one, but then when you will create a new house, you will say 4 to 4 3 null 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 null. Similarly, another house may be somewhere maybe more trues or false, and then no values for that, right? So this is again a problem here. If we done so, the builder design pattern tell us if we have a complex product like this one, where we are going to have a number of subclasses, create step by step. Okay, so define a builder class here and say build walls, one function, build doors, another. So these build walls will add to that build doors, build windows, build roofs, build garage, and then get result you will get the house. Depending on what you are adding, so you will get the house. You're not saying that these in a one function call. So you have all thing in step by step. Okay, so builder one now can be of wood and glass. Like, so you want everything to be constructed with wood and glass. You want something with stone and iron. You want with maybe gold and diamond. So you have a builder one, builder two, builder three. So can be you can have a different builders, and all of those builders will help. You can, when you will build the home in step by step, so you can pick any builder, and accordingly all of the house can be created. Okay, and then you need a director here that will set the builder and define the order of the steps, and builder provides the implementation, and director is actually optional. So this is our builder design pattern. So we have an abstract builder that declares the product construction steps that are common to all types of builder. So you define what are the construction steps that are common to all types of builders. So that's the abstract builder, right? So similar to the abstract creator. So we have the abstract builder. Then we have the concrete builders. So different implementation of construction steps. Then we have the products. These are the resulting objects. Products constructed by different builder. Don't have to belong to the same class interface. Can be different. Then we have the director. It defines the order in which the call construction steps. We can reuse specific configuration of the products. Then we have the client code. So it associates builder object with the director. So okay, so that's the director. That director defines the order, and builder defines what products needs to be created. So when creating the director, the builder is passed as the constructor. So when you're creating the director, you pass that I want this builder for this director. So the client code associates that. We can also pass the builder object to the production method of the director. Okay, so let's see this example. So this is a builder pattern. So our first step is create the builder, and the builder will have some reset step in case you want to start again. So there will be a reset. Okay, then we have the build steps A, build step B, and build step Z, and you can have a lot of steps here. So that's the builder. Second step will be to create concrete builders. So you will have a result will be the product one, and their result will be the product two, and you may have again build step A, build step B, build step. You will implement these, and finally will give you the product one, right? And here we'll get the product two. So that's the our third step. Get the product one and product two. Then we have the director. So director will have some builder, that which builder to be used, and we associate with this, and then change builder. You can change builder also and then make something, and this is how it is there. So make is first reset the builder, and then we're saying if type is simple, then build step A, else build step B, or build step Z. So you can have different products here. Make so you can say, okay, I want very minimal things only, very simple house. I want lot of things, or I want media or customize. So you can define these steps according to that. So this director can create the products, can pick these steps and do that, and you can pick the builder here. Okay, so you can set the feature, and then you can get this result. Let's see in this action the coding. So we have these libraries builder. So we have the product one, and product one is, let's say that we have a vector of the parts, because there are a lot of things to be created, and all of those things will be added to this vector, right? So the house will have some garage and windows and doors. So everything will be parts, and each of these steps will add to this vector, which is the parts, right? So parts is a vector of string, and list parts will list whatever parts you have added so far. So that's the list part. So that's our product one, and list parts, this is the implementation of this part. It goes in a loop. We are going to print everything that is inside these parts. Now we have the class builder, right? So that's our first step, builder. So we define the destructor, and we'll say produce part A, produce part B, and produce part C. And we may have different versions, and doesn't specify that how these products are produced. It just say it's a virtual all the functions are virtual, and we say builder says create product A, product B, and product C, and they are pure virtual. Now we have the concrete builder. So concrete builder will create the actual products, right? So in this case, we will define the implementation of the produce part A, produce part B, produce part C. And what it essentially does is it just adds the pushback into the parts. Okay, so we have destructor will have default destructor, that's the constructor, and we have the reset method that will reset everything, and this get product will return the product created by these implementations. So let's see this. So this is the concrete builder one, right? So this is the concrete builder one, and here we are going to have the constructor. So the constructor first reset. So if there is something, so it say, okay, I'm starting from the blank. So that's what the concrete builder one does. Then we have the destructor. It deletes that product. So in case you have already done with that, so it releases this memory, delete this product. Then we have the reset. Reset will say, okay, now I'm going to create the product one. So the product one, as we know, it starts, it's the beginning, right? So it will create a new product and assign to this product. So that's the reset. So when it's the constructor, it will call the reset. So when you call this constructor, it will call the reset, and reset will create the new product for you. Now we have the produce part A. When you pass the produce part A, so you're essentially doing is something is adding to the this product part. So we are adding this to the parts vector. So when you say produce part B, you added this something to the parts vector. Again, you C, you add something to the part. So all of these products are adding some values to the parts, right? So that's the products are created. Then we have this get product. So get product will will start from this product, that's the result, and it reset and then return the result. Okay, so as you can see in here, so this is the get product. So get product returns us the product. So just reset. I mean, it starts from the new product and it returns. So that's the get product. And what it does is, before that it resets, it actually returns your product. So this product is the product that you have built, and how in step by step. So it gets this and then it resets this. This is reset, but the result is already there and that's returned to you. Okay, so now we have the director. Director, as we know, associates this. So it gets the builder. We assign the builder to first. This is the set builder. So in the director, we'll call the set builder. So which builder you want. So there may be different builders. So you get the builder and assign to the builder. And then in the director, you can have like build minimal viable product. So I just want very minimum, and then maybe build a fully featured product, or maybe some customized version. So you can define all the steps here that needs to be done here. Okay, so now in the build minimum viable product, so you will say this builder product part A. So if it's a minimum viable, so we'll just have a product part A. If it is a fully featured product, then we have A, B, and C. Like you can think of like we are building a car with different component and different versions of that. So there is an SU version, hatchback version, and all of those things, and different parts are added to that. The client code is associate builder object with the director. So that's our client code. So in this case, we get the director, and then in this director, we have, okay, this client code. We can have one client code or we can have multiple client code. So in this case, we are having the builder one. We are associating this director with the builder one. So now all the products, this director is going to build that is will decide the flow of your steps, but actual builder will be used from here. So we are saying director dot set builder. So we set this builder here, and now we are saying director build minimum viable product. So but builder is this one. So all of this build minimum viable product will produce A, produce B, and produce C, and all of these will be used here. And then finally we'll get product. So get product will return the product, and you can list the parts here, and you will get all of those parts, and then you can finally delete this. Similarly, we can have another builder here. We can have a build minimum. I think this is simple. So this is the client code one with director, concrete builder one, and build minimum viable products. So this somehow this is a repetition. So client one, build minimum product list, and this one. So this is example one. Then we have the another example two, where we have the client code two. It gets the director, and we have the concrete builder one. So it should be two here. Example, what's the difference here? Yeah, concrete. So yeah, okay. So we are doing it here. Build fully feature product. So we are still using the builder one, but here in the example one we have the build minimum viable product. So with one we have the build minimum viable product, and next we have still with builder one we are going to have build fully featured product and get the product. So build a fully featured product is defined in the director code, and that can add all of those versions here. Then we have a custom product. So we have concrete builder one. In case we have the custom product, maybe A and C needs to be added. So builder will produce part one, builder produce C, and then you can customize the product here. Right. So you don't need to call the previous versions, but you can customize it here in the client code. Right. And then we can use the get product and then list the parts and then delete. That's our main. So we get the director and we pass this director to the client code. And if we pass this director to the client code 2 and we pass this director 3, so in this client code, we'll get the product of minimum viable. This will be fully featured, and this client code will develop the product with the customized product. And this is what you can see here. This is a product basic part A1, and this is a fully featured product A1, B1, C1, and this is a custom product which is the A1 and C1. And this is an example where this can be used, like we have this is a builder template interface, and this is our an example of the car. For example, we need to define builder, director, and we can have a car builder. We have a car manual builder. So as we are adding the parts into this in the car, so we need to create a manual also accordingly, right? So we can have a manual class here. So parallelly we are implementing the manual. So this will give us the car, and this will give us the manual. So this is the car builder, and this is the car. So we have a different builder here. So like we have concrete builder one. So in the previous example, we have used only the builder one. So but you can have a builder two, and parallelly you can create this. And when you say create minimum viable feature product, so you can use this builder and it will create only that builder class. Similarly, in manual car manual, you will get you can pass a different builder that will, with the same configuration, you will get the manual, right? So this will be your exercise to create the car example. Thank you.